Okay, now today we are going to see how to prove that two angles are similar to each other. So tell me, if I want to prove that two angles are congruent to each other, which tests are there to prove that two triangles are equal? Yes, or congruent. ASA test is there, SAS test was there. So same test we are going to use to prove that two angles are similar to each other. Now what do you mean by similar? So we say that it is similar but not congruent because sides are in proportion, though the angles are congruent, but so size of these two triangles are different. Okay, so wait, we will see now how to prove that two triangles are similar to each other. Okay, so similar triangles. In triangle ABC, here you can see there are two triangles, that is triangle ABC and triangle DEF. Angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and sides of these triangles are in proportion. What does it mean? So see, if you see, whenever we are saying, see, this angle is congruent to this angle. So side opposite to this angle, that is DE and AB, will be in proportion. So see over here. Okay. Now, if you see, if we consider this angle and this angle, these two angles are congruent. So the side opposite to these angles will be in proportion. So see over here, AC upon DA. Okay. Now again same thing, if you see this angle is congruent to this angle, so side opposite to this angle will be in proportion to this angle. So look over here, BC upon AM. So this is how we say that two triangles are similar. So in the case of similarities, the angles will be congruent to each other, but side won't be congruent to each other, but their ratio will be equal. Okay, so that we can say that triangle ABC and triangle DEF are similar triangles. And to show two triangles are similar to each other, we use this sign. And in case of congruency, we use this sign, or either this or this. But mostly we use for congruency, we use this sign. Okay, and for similarity, we use this sign. I guess everyone knows this, right? How to prove that two triangles are similar in different cases. Okay. Now we will use AAA test. AAA test suggests that is angle. So all three angles of your triangles are congruent. Then you can say that these two triangles are similar to each other. Let's suppose in triangle ABC and triangle PQR, angle A is congruent to angle B, angle B is congruent to angle Q, and angle C is congruent to angle R. Therefore, I can say that triangle ABC is similar to triangle PQR. Now, the ratio of their sides, AB upon PQ, AC upon QR, AC upon PR. So basically, so this is PR, okay. Okay, so see, the side opposite to these two angles are congruent. So the side opposite to this will be AB and PQ. So their ratio. So first one is done. Okay, now side opposite to B and Q, that is AC and PR. So AC and PR, okay, done. Okay, now angle A and angle B is congruent. So side opposite to them. So the side opposite to them, or you can say side in front of them. So this is BC upon QR. So this ratio is there. So this is how you will find out the ratio of two sides of two triangles. Okay. Now this is the one test by which you can say that two triangles are similar to each other. Okay, so for here they have proved that how to identify which side is proportional to which side. So here, if A is congruent to P, then BC is proportional to QR. BC upon QR are in proportion, or AB upon PQ are in proportion, and AC upon P are in proportion. So this is how they have proved that using your basic proportionality theorem. So what they have done is they have drawn Mn that is parallel to BC. So according to basic proportionality theorem, this will be Am upon Mb will be equal to An upon Nc. Okay, but in this case, what they have done, they have drawn this Mn side such that, or they have drawn this Mn parallel such that this triangle AMN is equal or congruent to your triangle PQR. So basically these two triangles are congruent to each other. Okay, and stop drawing. Okay, so after that, according to basic proportionality theorem, this is Am upon Mb is equal to An upon Nc, that we know. So what they have done is invertendo. So this denominator will come to the numerator, same thing for the Nc upon An, and after that they have done componendo. Componendo means you have to add your denominator to the numerator on the both the side. So Mb upon Am is nothing but your AB side, and An plus Nc, An plus Nc is nothing but your AC. So here you can see AB upon Am is equal to AC upon An. But since these two triangles are congruent, that is this AMN is congruent to PQR, they have replaced AM by PQ and PR. And this is how you can show that AB upon PQ is equal to BC upon QR is equal to AC upon PR. This is just an extra information. So we will proceed. So next test is AA test. AA test means if you prove that the two angles of your triangles are congruent, then also you can say that two triangles are similar. Let's suppose you have triangle ABC, or we will take LMN. Okay, so this is triangle LMN, and this is triangle, let's say DEF. Okay, now angle L is congruent to angle D, and angle M is congruent to angle E. So can I say that these two triangles are similar to each other? According to AAA test, that we know that two triangles are similar. But according to AA test, whether they are similar or not, see, if this is 60, this will be 60, right? If this is 50, will it be 50? Now, what we know, the sum of angle of triangle is 180, right? To find out third angle, we already have two angles over here, right? So sum of these two is how much? 110. So this angle will be how much? 70, right? Same is the case of this. If I have two triangles out of 3, and plus what I know, the sum of angles of triangles is 180, right? So don't you feel this will be equal to 70 only? So if you are saying two angles of our triangles are congruent, ultimately the third angle will be congruent, because your two angles are already congruent. The addition of those two, if we subtract the addition of those two from 180, you will ultimately get the same angle of the other one, right? So basically, if two angles are congruent, the third will be congruent to the third angle of other triangle. Yes, understood? AAA is also valid and AA is also valid. Okay, then you have SAS test. So in case of congruency, what we used to do is, in case of SAS test, we used to show two sides are congruent of your triangle and one angle is congruent, right? In case of congruency. But in case of similarity, what you have to do is, suppose you have these two triangles. Okay, now in this case, if you see, angle L is congruent to angle S. Okay, so this is one thing, this is given. Okay, but now you have to see that the ratio. So what will be the ratio of this? So if angle L is congruent to angle S, so the ratio will be Km upon RT. Then you have KL upon RS, and then you have LM upon ST. So we need to look for this ratio. So now if you see, this is 1 upon 1.5. I will multiply by 10 on the both the sides. So I will get how much? 10 upon 15. So if I take 5 as a common factor from numerator and denominator, I will get 2 by 3 as ratio of what? KL and RS. Now I will look for LM and ST. So it is already given that it is 2 by 3. So now I got the ratio of two sides are equal, plus I got the angles are congruent. That means according to SAS test, I can say that triangle KLM is similar to triangle RST. We might have showed that KL is congruent to RS and LM is congruent to ST, and angle L is congruent to angle S. And then we might have said that this if two sides are congruent and one angle is congruent, that means according to SAS, two triangles are congruent to each other. But in this case, we don't have congruent side. We do have two sides which are in proportions. So what we have to prove that the two sides are in proportion and one angle is congruent, then we can say that these two angles, these two triangles are similar to each other by SAS test. So after this, you have triple S test. Now in case of congruency, what we used to do is, we used to prove that all three sides are congruent. But now in this case, what you have to prove is, you have to prove that three sides are in proportion. Okay, so here what we are going to do is, we are going to prove that the side of one triangle is proportional to the side of other triangle. So the ratio of sides of two triangles are in proportion, then we can say that triangle PQR is similar to triangle XYZ. I guess we have done this in 9th standard. We have proved this, right? We also use this theorem, use this test to find out the unknown side. Do you remember this from 9th standard? You must have given this side as 3, this as 1, then this as something, let's say 1.5, something like this. So you need to find out the unknown side. So we have used this property to find out the third side or the unknown side. So we are going to use, so here what we are going to prove that the ratio of these triangles are equal. That's it. So what you have, we have triple A test, then we have double A test, then we have SAS test, and then we have triple S test. Okay, so by this test we can prove that two triangles are similar to each other. Okay. Reflexivity, so this is symmetry, and third property is transitivity. Okay. Okay, so these are the problems. We won't go, we will directly solve the exercise 1.3. Okay, now in this exercise, so what you have in figure 1.55, state which two triangles are similar and by which test. Also write the similarity of these two triangles by proper one-to-one correspondence. Which two triangles are similar and how? Take out your notebooks and solve this. So they have given us this angle is congruent to this angle. So instead of doing this, what you are going to do in this case, when you have two triangles in between, you will draw this on the other side. So this, let's suppose this is your D. Okay, so this is your D. Okay, and then this is C. This is E. So I have done this like this. Okay, now tell me which angles are congruent. Now by which test these two triangles are similar? So you have triangle ABC and then you have this small triangle in between. So by which test these two triangles are congruent? Yes, by AA test you can say that the two triangles are congruent. Now, sorry, not congruent, similar. So look over here. They have given angle D is equal to angle B. So we have one angle over here. Okay, so this is our one angle. But if you see, don't you feel this angle C is common? Yes. So in both cases, this angle C will be equal to angle C. So if you see in triangle ABC, I can write it as angle ACD is congruent to angle DCE because both are same angle. Yes, so this angle is congruent. So by AA test, I can say that these two triangles are similar to each other. Side A, so now angle B is congruent to angle D. So the side opposite to D and side opposite to B. So now we will consider angle ABC first. So side opposite to angle B is AC, right? Upon that we will write the side of triangle DCE or EDC, whatever. So here it will be EC, right? Now we will write down the sign opposite to now second congruent angle is which one? Angle C1, right? So we will write down the side opposite to C, which is AB, right? In the bigger triangle, and in smaller triangle it is DE, right? And after that we will write down the remaining side, that is opposite to A. So basically angle A is congruent to angle E. So now in this case, how will you identify the third side? So this will be equal to this side, that is BC, and then we will consider the smaller triangle, that is EC. Write down the first one. You have to write down the given first, okay? Then write down these two triangles, okay? After that you have to show that angle B is congruent to angle D. So this is given. Write down second statement that angle ACB is congruent to angle DCE because both are common angle, okay? And after that say triangle ABC is similar to triangle ABC, right? So triangle ABC is similar to triangle EDC. While writing also, make sure that you are writing two angles congruent. So angle A is congruent to angle E. So I have written angle A. So I have started with angle A. So here I have started with angle E. Then after that I have said that triangle ABC. So I have used B over here. So angle congruent to B will be angle D. So D over here. And then C is congruent to C. So I have written triangle ABC is similar to triangle EDC. So you have to write in this way only. Write down regions properly, okay? Don't forget to write regions while writing any statement. If you see in next question, are the triangles in the figure 1.56 are similar? If yes, by which test? So if I write PQ upon LM, which is equal to 6 upon 3, which is equal to 2 upon 1. Okay, so this is my first. Okay, second thing will be, let's say QR upon MN. So this will be equal to 8 upon 4, right? So this will be again 2 upon 1. So this is second statement. Okay, and the third one I'm writing over here. So this will be PR upon LN will be equal to 10 upon 5, that is 2 upon 1. This 3. So from 1, 2 and 3, from 1, 2 and 3, PQ upon LM, PQ upon LM is equal to QR upon MN is equal to PR upon LN. So according to triple L test, I can say that triangle PQR, so triangle PQR is similar to triangle LMN by triple S test. So in figure, two poles of height 8 and 4 are perpendicular. So perpendicular means what? This angle is 90 degree, right? If the shadow perpendicular to the ground, if the length of the shadow of a smaller pole due to straight sunlight is 6 meter, so this is 6 meter, will how long will be the shadow of the bigger pole at the same time? Okay, so here there are two poles, okay, and so basically if you see triangle ACB and triangle PRQ are similar triangles, okay. So basically PR upon AC will be equal to, so PR upon AC will be equal to QR upon BC. So this is 4 upon 8 will be equal to, QR is how much? 6 upon X. So X will be equal to 6 into 8 upon 4, that is X is equal to 12 meter. Okay, so if you see, what I know, these two are perpendicular to each other, that means this is 90, so this is straight pole. Okay, so one angle we know, one side we know. Okay, the other thing is sunlight. Okay, so sun must be over here. So this is the angle of depression. So the angle of depression over here is equal because it is at the same time. So this angle must be equal. So there is angle of depression an angle of refraction over here. So because of which we can say that these two angles are congruent. Yes. Now in this case, yes. So to that triangle CPA. So CPA means, okay, so CPA, so this triangle, okay, so one triangle I know, and then CQB. Okay, this is the easiest one. Yes, prove. How will you prove that this triangle, so this triangle and this triangles are similar to each other? Yes, angle CQB is similar to triangle APC or CPA or AAA or AA. It will be ultimately AAA, but first of all, the third angle is not given. Only two angles are given, which are those Q and P. Okay, that will be the one pair, which will be the second pair of congruent angle. So C is basically common angle over here. So if you see, what we have is angle APC is congruent to angle PQC. This will be one point, and the second point will be angle let's say QC. So this is Q. Okay, QCB is congruent to angle PCA. So from 1 and 2, we can say that these triangles are similar to each other. So this for this common angle reason, and for this both are 90. Both are 90. Give reason at each and every step. Okay, so by AA test, write down in this format, we can say that these two triangles are similar. Now we need to write down the sides. Okay, so we want to find out AC. Okay, so AC is opposite to which side? Angle P. Okay, so we need to find out sides which is opposite to Q. So AC upon BC will be equal to, so which one is given? BQ is given, which is opposite to your C. So BQ upon AP. Sorry, AP upon, you will have PQ. Okay, so this will be equal to, so let's suppose let AC is X. So this will be X upon BC is how much? 8 is equal to AP is how much? 7 upon PQ is how much? 12. So this will be equal to 7 upon 12 into 8. Is it correct? This will be 2 za. So this will be 14 upon 3. So this is 4.66. Now in this case, what do you mean? What are the properties of trapezium? So basically in trapezium you have opposite sides are parallel. So this is your trapezium. Okay, so PQ is parallel to SR, and they have given that AR, which is AR over here, is equal to 5 AP. So we will write it in this form. So AR, write it over here, AR is equal to 5 AP. So can I write it as AR upon AP is equal to 5 upon 1, right? And AS, so AS upon which one? AQ is equal to 5:1. Right? Yes, everyone. This is given. See, what they have given, AR is equal to 5 AP. If I want to take this AP on the left hand side, since it is here, it is 5 into AP. When it will go on the left hand side of equal to sign, it will come in the denominator. Yes, correct. So AR upon AP is equal to 5/1, and same is the case for this. Okay, now we want to prove that SR. So this side upon PQ, SR upon PQ is 5:1. Now which sides are given? So they have given this AR, okay, then they have given AS, okay, and then AQ. Okay, so basically we need to consider these two triangles. Okay, so you have triangles, so we have to consider these two triangles. So this is one triangle and this is the second triangle. Okay, so what we are going to do, we will say that in triangle, let's say PAQ, and triangle which is other one, that is RAS. So in triangle PAQ and RAS, we can say that angle PAQ is congruent to angle RAS. So basically I have proved that these two triangles, these two angles, so this angle and this angle are congruent. Why? So these are vertically opposite angles. To give reason. Okay. After that, what we know, these two are parallel. So I can say that angle P is congruent to angle R. So angle QPR is congruent to angle, not R, A, it should be A, is congruent to angle ARS, alternate interior angle. So by AA test, I can say that triangle PAQ is similar to triangle RAS by AA test. So if these two triangles are similar, I can say that the side opposite to A is SR on PQ should be equal to let's say AS upon AQ must be equal to AR upon AP, right? And this 2 is given, but AS upon AQ is equal to AR upon AP is equal to 5/1. From 1 and 2, say call it as 1 and call it as 2. So from 1 and 2 this is given, therefore call it as 3. From 3 you can say that SR upon PQ is also equal to 5/1. Therefore SR is equal to 5PQ. So write it down properly. So what you have to write is, first write down this and this, call it as 1 and 2, and for this give reason as given. It is given in your example. Okay. After that, write down this statement that these two triangles are similar. So by which states? So opposite two angles are congruent and alternate interior angles are congruent. Therefore, these two triangles are similar by AA test. Then you have to write down this statement, because these two triangles are similar to each other. That means the sides are in ratio, but from 1 and 2, this is given. So I can say that SR upon PQ is also equal to 5:1. So SR is equal to 5 PQ. Next one is also trapezium. So ABCD is a trapezium where AB is parallel to CD. The diagonal AC and BD intersect at point O. If AB, so AB is 20, DC is 6, OB is 15, then find OD. So here also you have to prove that these two triangles, so basically this triangle, this one, the smaller one and this bigger one are similar by same test. So basically what you are going to do is you are going to prove that these two are vertically opposite angles, so those two are congruent. Plus, since this is a trapezium and CD is parallel to AD and CA is your transversal, therefore the angle C is congruent to angle A. Both are alternate interior angle. So by double A test, these two triangles are similar to each other. Okay, after this, yes, everyone done with problem 5th one? Yes?
Yes, ma'am.
Yes. Okay, so I will clear this. Okay, so basically you have to use same double A test over here. So these are two vertically opposite angles, so these two are congruent. Then these are alternate interior angles, so these are congruent. So triangle, let's say COD is similar to triangle COD. So AOB. Therefore, you can write down therefore BA or AB upon CD is equal to OD upon OB is equal to OC upon OA. But then you have to write down AB is 20, this is given, DC is 6, this is given, and OB is 15. Therefore, let OD is X. Therefore, AB is 20. So we will use this. AB is 20 upon CD is, or DC is 6, is equal to OD is how much? We don't know. And OB is 15. Okay. It should be OB upon OD. So this should be OB upon OD. This will be 15 upon X. Don't make mistake over here, okay? Otherwise you will get stuck over here. So this will be X is equal to 15 into 6 upon how much? 20. So this will be 4, this is 3, this is 3, this is 2. So this will be X is equal to 4.5. Yes, correct? Yes, everyone? Understood? Write it down. So you have to first prove that these two triangles are similar, then find out the fourth side using proportionality theorem. Proportionality property of similar triangles. In next problem, if you see, this is the parallelogram, that is ABCD is a parallelogram. Okay, and point E is on the side BC. Line DE intersects ray AB at point T. Prove that DE, so DE into BE into BE is equal to CE. DE into BE is equal to CE into TE. Okay. So here what they have done. Okay. So you need to prove this. Okay. Do one thing. first of all, prove that this big triangle is similar to this triangle. Okay. So if you see, what you have to do is write down in triangle. Let's suppose in triangle we will say DEC. So in triangle DEC and triangle DET, these two angles are congruent by vertically opposite angle. So angle DEC is congruent to angle BET, vertically opposite angle. Now what other thing we know, that these two sides are parallel to each other. Why? Because these are the sides of your parallelogram, right? So if we consider BC as our transversal, then don't you feel these two angles? So angle C and angle E will be congruent. So these will be your alternate interior angle. So angle EBT is congruent to angle ECD. Yes. Why? Alternate interior angle. So by which test? Double A test, I can say that these two triangles are similar. Yes. So these two triangles are now similar. So after this, we have shown that these two triangles are similar. Now we must find out the pairs of sides. Okay. So since E is congruent to this E, so that means TB upon DC should be equal to, now B and C is congruent, that means TE upon ED or DE. Okay, and next thing is which side is left? Okay, so BE upon CE. Okay, so this is how the sides are proportion. Now if you concentrate, we will take these two sides ratio. So this is what? This is equal to, this is equal to TE upon DE is equal to BE upon CE. So if I cross multiply this, so I will take this to this side and this to this side. Don't you feel this will be equal to TE into CE will be equal to BE or DE into BE, or you can say DE into BE is equal to TE into TE. Okay, write it down. So basically you have to prove that these two triangles are similar. After that you have to show the sides, and after that you have to take two sides from that and then show that these are equal. Segment AC, okay, AC and BD intersect at point P, each other, and AP, so this is AP upon CP is equal to BP upon PD. So this is very easy. What you have to do is, you have to take these two triangles. So take triangle APB, so APB, and triangle APB, so triangle CDP. Okay, so you have to prove that these two are similar. So CDP. Okay, so what you will tell, that AP upon CP is equal to BP upon PD. So this is given. Okay, So two sides are in proportion, and then tell these two angles, that is angle APB is congruent to angle CPD by vertically opposite angles. So by SAS test, these two triangles are similar to each other.